Hello learner, welcome to the learning of computer networks and security. Let's continue with the module 3 concepts. Let's discuss about hierarchical routing. Here already we have seen the routing algorithms. This is the continuation part. First, let's see here what is hierarchical routing. As you all know about the networks, basics of networks, so it is something like if I take a network which consists of group of routers. So practically saying, network is a very vast thing, wide thing, where you have n number of source nodes, n number of nodes here in the network, wherein some of the nodes we can take it as a source node and some of them we can take it as destination. Suppose if I have a node sending messages or the data to the destination can be one destination node, or it can be hundreds of destination node, or it can be thousands of destination node, or it can be millions of destination node. So it is something like when you're sending the data, multiple sources may send the information or message to millions of destinations. So here whenever this message or the data passes or the packet passes in the network, it has to pass through multiple routers in the network. So all these you call them as routers, intermediate nodes, right? So here practically seeing, there are n number of thousands of routers in the network. So what happens as the number of destinations increases? As the number of destination increases, these millions of routers also will come into picture. So maintaining such routers, or in other words, each router has to maintain something called as the forwarding table. You have already seen what is a forwarding table, right? So whenever a packet arrives, that information about the packet should be entered here in the routing table. So information, when I say, it may be the address, source address, destination address, or the subnet address. So that information must be maintained in the routing table. So that will help here in calculating the shortest path, or the router here with the help of the forwarding table or the routing table will calculate the shortest path for the packet. So the packet next can easily reach or quickly reach the respective destination, right? So here all these routing tables maintained here at the routers will help out in calculating shortest path. But when the number of destination increases, the number of routers also keeps on increasing, and therein the routing table also increases. So maintaining such multiple routing table becomes difficult. So here we have a solution here, that is something called as hierarchical routing, where the group of routers, or in other words we can say the routers are grouped in together, multiple routers are grouped in together, and each such group here we call them as autonomous system. So each such system here will be following the same protocol, or each such group will be following the same algorithms. Okay, so all these routers will behave similarly. So instead of maintaining individual router, here we'll be maintaining a group of router, which we call it as autonomous system. So we call them as now hierarchical routing. As I already said, autonomous system. So what is the meaning of autonomous system? So autonomous system, when I say, it is something like a system which follows same rules and regulations throughout, right? So if I have an autonomous system wherein the system contains multiple routers inside within it, or you can call it as a group of routers which are all connected with each other, which are all connected with each other. These are all the routers which are all connected with each other, and all these routers follow same set of rules. What do you mean by rules here and regulations? It is nothing but the protocols in the network. So here all these routers will follow the same protocol in order to forward the packets, or else you can also call it as all these routers will implement same routing algorithm. It can be the link state algorithm or distress algorithm. So it is the same routing algorithm, common routing algorithm, which will be followed or implemented here by all the routers within the single autonomous system. So that is the meaning of autonomous system. Okay, so here we have two sets of protocol. One we call it as intra-AS protocol. What do you mean by intra-AS? So it is within the autonomous system. Within the autonomous system, all the routers will follow same routing protocol. So I will tell you about the different types of protocols we have here, but right now you just see that it is intra-AS protocol we call. It is within the autonomous system, all the routers follows the same protocol. Okay, so it is about this. And again we have something called as a gateway router. So what is gateway here? I said it a group of routers forms a single autonomous system. So here there must be some router within the group which connects to the outside world. So what is the meaning of outside world? There might be other autonomous system which we call as outside world here for this autonomous system. So let me call this as autonomous system 1 and this as autonomous system 2. So here two autonomous systems. Suppose if I have to send a packet from this autonomous system to the other autonomous system, in that case there should be one router which will be connecting me to the autonomous system 2, or in other words there should be some edge router here in my autonomous system, in this autonomous system, which connects to the outside world. So what is that edge autonomous system? So among these multiple routers there will be one autonomous system, there will be one router which we also call it as gateway router or edge router, which connects to the outside world. So here let me call this as my organization, our college, our organization. So you can call this as our neighboring organization, neighboring college. Okay, so here suppose if I have to send any data or any information, message or email to the other organization, I would be sending the message through this gateway router. So this is the gateway router through which my message will be transferred to the outside organization, other organization. Similarly here in this other organization also there must be one gateway router which will receive this incoming information, and through this gateway router that message will be passed to the required destination router or the destination system. Okay, similarly here inside my organization, not only outgoing, also the incoming messages arise through this gateway router. So I hope you understood what is gateway router or edge router here. Now let us see what about this autonomous systems, how the messages or packets are getting transferred between the multiple autonomous systems. So in this diagram you can see three autonomous system, AS1, AS2 and finally AS3. You can have a look at this individual autonomous system. So in this autonomous system 1, you can see there are three routers. So it is a group of four routers. It's a group of four routers. So router 1A, next you have router 1B, then you have router 1C and then you have router 1D. All these routers are interconnected through this thick lines you can see here, and you can call this as the links between the routers. Okay, links between the routers, and you can see few thin lines here. So what are these thin lines indicating? It is indicating the subnets. So it is nothing but the subnets which are connected to these routers. So here these routers will be connected to some host there, or these hosts are all connected through the subnets, and every such host will be having some subnet address, right? So about that you might be knowing about the subnet addresses. So all these are called subnet subnets. 1C is connected to 2 subnets, 1A router is connected to 2 subnet, 1D router is connected to a single subnet, again 1B router also is connected to a particular subnet there. So here same thing you can see in autonomous system 2 also. I have 3 routers, 2A, 2B, and then finally 2C. Similarly in AS3, autonomous system 3, again I have 3 routers, 3A, 3B, and 3C. And among these routers here in AS1, I have 2 edge routers. You all can see one edge router is 1B, the other edge router is 1C. So why do I call this 1B as edge router? Because it is the router which connects to the other organization or the other autonomous system. So 1B is the one which connects to AS2. Similarly, inside AS2 I have 2A as a edge router, one edge router, that is 2A. Similarly, when it comes to AS3, I have one edge router, that is 3A, which connects to our AS1. So here 3A, 1C, and then 1B, and then finally 2A. All these are called as edge routers or gateway routers. So inside this autonomous system, I have intra-AS routing protocol implemented. So what is the meaning of intra-AS? Intra-AS, it is nothing but inside the organization, within the autonomous system, all the routers should follow the same algorithms or the same set of protocols. Okay, so here again when I come to AS2, here also inside this intra-AS routing algorithm is used. Here also in AS3, intra-AS routing algorithm is used. What about this inter-AS routing algorithm? So this inter-AS means across the autonomous system, there must be some algorithm or there must be a protocol which should be implemented in order to interact between the two organizations or the two autonomous system. So the protocol that is used to interact between the two gateway routers or the algorithm which is implemented to route the packets across the organization, you call it as inter-AS routing algorithm. So here between AS1 and AS2 and then between AS3 and AS1 also there should be some inter-routing algorithm which should be implemented. Remember, it is the gateway routers which should implement this protocol or algorithm. It is only the gateway router which should implement that. Okay. And you all can see here every router maintains the forwarding table. So here you can see this edge router also should maintain the forwarding table, 1B, 2A, and then our here 1C is also edge router. This also should maintain, 3A also should maintain the forwarding table. So what information this forwarding table should have? It should have the information about connecting to the other organization. So that is the forwarding table maintained by the edge router. Along with that, every individual router inside the autonomous system also should be maintaining the forwarding table. So what is the information maintained in the forwarding table inside the organization? Maybe it is 1A, 1D. So what is that information? It is nothing but the data about or the information about routing shortest path to reach inside the autonomous system. Suppose here 1A has to send a packet. So here through the forwarding table, it actually can reach from with the help of forwarding table, it can calculate the shortest path, and finally this 1A can reach to any of the node here inside the autonomous system. So here shortest path can be calculated. For example, if 1A has to send the message to say 1C, you can see here what is the path to reach from 1A to 1C. You have one direct path. I guess there is only one path. Forget about 1C. If I have to reach 1B, the node 1B, so from 1A to 1B, I have two paths. One is via 1D, I can reach 1B, or else there is a direct path that is from 1A to 1B. So there are two paths. So here with the help of the forwarding table that 1A has, it can calculate the shortest path with the help of maybe Dijkstra's, or it can be link state algorithm, Bellman-Ford algorithm. Any one of the algorithm can be implemented and calculated, shortest path can be calculated. So that is how inside the autonomous system the shortest path is calculated, and that information is maintained within the forwarding table there. So you can see here intra-AS set, and that is for inside internal destination. Suppose if any router wants to send packet inside here within the autonomous system, then intra-AS set entries should be done in the forwarding table. Inter-AS set entry is nothing but if a packet has to be sent to outside the organization. If a packet has to be sent to the other autonomous system, in that case inter AS set has to be done. That means the gateway routers has to maintain the information in the forwarding table, so wherein the shortest path is calculated to reach the other organization, not inside the organization, the shortest path to reach the outside the organization. Suppose here if 1A is a router which wants to send a packet to a router, say 2C. So how the packet will be forwarded? First, 1A has to calculate the shortest path to reach one of the edge router inside the AS1. So it can be 1C it has to reach, or it can be 1B edge router which it has to reach. But we know that here 2C is the destination. If 2C is the destination here, 1A is the source. 1A can reach here, 1A can reach this destination 2C only through the edge router 1B. Why? Because the link between AS1 and AS2 is only through 1B and 2A, right? So but how will our router 1A comes to know about that? What is that 1A should come to know? See, 1A will know that the destination is 2C, right? So 1A will know the destination 2C, but 1A also should know that how it can reach 2C, or via which router inside AS1 it can reach this node or the router 2C. So here there are two edge routers, it is 1C or 1B. So here 1B is a router through which it can reach actually the destination 2C. But whether 1B edge router, who will, 1A should come to know about that, right? So it is actually the duty of this router node 1B to tell about all the reachable nodes via 1B. So 1B first has to calculate the distance, or the shortest distance, or all reachable routers via 1B. Okay, or in other words, it is something like, suppose here 1B is a edge router in this AS1, right? So 1B should know what are all reachable routers inside autonomous system, within this autonomous system. So what is that information? 1B should know that 1D, 1A and 1C are the reachable routers inside this autonomous system. So that information is shared. About that information it should share with the other edge router 2A, which is actually part of AS2. So can 1B share that information with 2A? Because both are gateway routers, so they can share this information among each other. Similarly, 2A also should know that which are the reachable routers. Not only reachable routers, it can also be about the reachable subnets inside this organization. So about that information, who should know? It is the edge router or gateway router should know. 2A should know about that. So here, whether 2A will know about the destination 2C, definitely it will know. So that information will be shared with the gateway router 1B, and once gateway router 1B gets to know about that reachable router or the reachable destination here, so that 1B will propagate that information to all the routers inside this AS1. So that is how our 1A will come to know that the destination router 2C is reachable via the edge router 1B. So once it comes to know about that, 1A will forward the packet through the shortest path, it will forward the packet to the edge router 1B, and then again edge router 1B should calculate the shortest path to reach AS2 or the edge router 2A, and then again 2A should calculate the shortest path to reach the destination node 2C. That is how through the shortest path the packet will reach from source to the destination, and that is how the packet will reach, it will travel across the organization. So this is actually the concept of interconnected AS, or the routing of packets across the organization. So I have already told what is inter AS routing. So inter AS routing is just calculate, it is something like if a router 1A has to send the packet to the other organization or the subnet that is belonging to some other autonomous system. In that case, our router 1A first should calculate the shortest path. First should come to know which edge router it has to contact. So there can be multiple edge routers. So here 1C is edge router, 1 1B is also edge router. So AS1, inside this AS1, two edge routers are there. So here, since 1A is the source router, 1A should know that via 1C whether it can reach this destination 2C, or via 1B it can reach this destination 2C. So here anyways 1B will first find out that information. So 1B will first find out which are the destinations, or which are the nodes that is reachable via 1B. So here 1B can reach the edge router 2A. So via 2A it can reach all these nodes here. That information will be shared by 2A with 1B. Similarly 1C also will know about all the reachable nodes via 1C. Through 3A it will come to know. So 3A will know about all the reachable subnets here inside this AS3. That information will be propagated to 1C via this inter-AS routing protocol. So via inter-AS routing algorithm or protocol, 3A will communicate or propagate the information to 1C. Similarly 2A will propagate the information to 1B. So here via intra-AS routing protocol, 1C will in turn propagate the information to all the routers inside AS1. Similarly, using intra-AS routing protocol, our 1B also will propagate the information to all the routers connected here inside the AS1. You can see here how the forwarding table is set. So here you can see the forwarding table that is set. For example, to a router 1A, if I take the example of router 1A, you can have here 1A should once 1A finds the route, suppose 1A wants to send the data to the subnet, one of the subnets, say that subnet, let's name it as X, and if that subnet X is connected to the autonomous system AS3, that subnet's information first should be propagated to 3A, from 3A to 1C, and then from 1C to router 1A. So once 1A comes to know about the shortest path to reach this subnet X, that entry is made in its forwarding table. So router 1A will make an entry to its forwarding table. What is that information it will maintain in its forwarding table? It is the subnet, which subnet is reachable via which interface. So here X, L. So L indicates the interface. What is the meaning of interface here? Interface is nothing but the link. So link 1A to 1C, there is a link, you can call it as an interface here. So via that interface it will then reach to 3A, and then via 3A it can reach to the ultimate destination X. So that X is a subnet reachable via the interface L. So that information should be maintained inside the forwarding table of any router. Okay. Similarly, our edge router also will maintain the forwarding table. So there also you have an entry for this subnet X reachable via the particular interface. Okay, so that entry also should be maintained at the edge router. So one entry in the routing table of a source, again one more entry in the routing table of our edge router. Now you can see here, suppose if I have multiple path among the AS. So what is that multiple path? You can just see here. I have here the subnet X, which is actually connected to this AS3. Suppose here I have also a link to AS2. So what is the meaning of that? Suppose the subnet X is reachable from both AS3 and AS2. That means there is a link from the subnet X to AS2. Again, there is a link for subnet X to AS3 via some router. So here in this case, our source router 1A can reach the subnet X via AS3, or also it can reach the subnet X via the via the autonomous system 2, AS2. So there are two paths to reach the same subnet X. So which path the router 1A should choose? Always the router 1A should choose the shortest path to reach the subnet X. Right? So for that, shortest path calculation should be done first inside the autonomous system through intra-AS routing algorithm. So first shortest path is calculated. It can reach either 1B edge router. Through 1B edge router it can reach 2A, and finally it can reach the subnet X. Or 1A first can calculate the shortest path to reach the edge router 1C, and via 1C it can calculate shortest path to reach 3A, and via 3A it can again calculate the shortest path to reach the subnet X. So there are two paths to reach the same subnet X. In that case, which path is chosen? Always the shortest path is chosen through intra AS routing algorithm, or it can be through inter AS routing algorithm. So here we have the concept called hot potato routing. So what is this hot potato routing concept? You can see this concept is important exam point of view also. So hot potato routing is the one wherein it is something like related to the real world scenario. Can you hold the potato which is very hot for a long time? You cannot hold it in your bare hands, right? So it must be passed on somehow. So hot potato cannot be held for long time, it must be passed somehow, right? So the same concept is explained here in the network. So potato is nothing but the packet here. So the packet cannot be held at a router for a long time, it must be forwarded. So what is the meaning of that forwarding of packet? How it can be forwarded packet? So always the packet should be passed on very quickly. In order to pass on the packet to the pass on the hot potato to the destination, it should be passed on very quickly through the shortest path, right? So that is something like, now potato is the packet. So packet you cannot, router cannot hold it for long time, so packet should be forwarded to the destination. But how it can be forwarded quickly to the destination? It is only through the shortest path it can forward the packet to the destination. So hot potato routing is something like, you can see the step. First, if I take this as an example, router 1A is the source. Okay, so first through the inter AS protocol or inter AS routing algorithm, first it has to find out about the destination. So through which edge router the destination is reachable, that is the information first the source has to find out. Suppose if I have a subnet X which is the destination, or which is connected to the router 3A, and we know that AS3 3A is belonging to AS3. So this source router 1A also should know about that. Suppose source router 1A wants to send the message or packet to the destination subnet X, first through the inter AS routing protocol, through the inter AS, that is across the organization, first 1C should find out whether X is reachable through 3A. So if X is reachable through 3A, 3A will come to know about that, and since 3A is edge router, that information should be passed on to the other edge router 1C, which is a part of AS1, and once 1C comes to know about this X subnet X, that information should be passed through intra AS routing protocol. It should be passed to all the routers here inside AS1, and that is how our router 1A will come to know about the destination X. So once it comes to know about that, it learns the shortest path. It first finds the shortest path to reach this edge router 1C. So here we can see there is one path, that is the only shortest path to reach 1C first. So once through intra AS routing algorithm, it can be link state or Bellman-Ford, any one. So it is through intra AS routing algorithm, first it will take the shortest path to reach the edge router 1C, and again through, you can see the next step is using the routing information from intra AS protocol, that is to determine the least cost path. So what is that we have done? The least cost path is calculated to reach the edge router in the second stage, and after that hot potato routing takes place, and that is through the gateway. So what is that? Again, least cost path is calculated from the gateway router, that is the edge router, to the other gateway router. Least cost path is calculated, and after the least cost path is calculated through inter AS routing algorithm, next is the last step is determine the forwarding table, the interface I you can take, that leads to least cost gateway. So determine from forwarding table the interface that leads to least cost gateway, or finally you can enter that entry into the forwarding table. So what is the meaning of that? Once you calculate the shortest path to reach the final edge router, through that finally you can reach the destination subnet X, and that information now, what is that? This path information, which interface you have chosen to reach this destination subnet X, that information will be maintained in the routing table. So your routing table or forwarding table can be maintained at source node 1A. So once you make an entry, next time if at all you want to send a packet to this subnet, easily you can extract that information from the forwarding table, and directly you can reach that without calculating. Directly you can, through the shortest path only, you can reach that destination subnet X. So anyways, that shortest path information is maintained in the forwarding table. So this copy also should be maintained here at the edge router, so that forwarding table is maintained. So this is how hot potato routing takes place in the autonomous system.